In this episode of Art Tutorial, I will be teaching you three different and simple ways of finding the number of moles of substance. On the board, we have three different ways of finding the number of moles of substance. The first one is using the Avogadro's constant. The second one is using molar volume of gas at STP, and the last one is using mass and molar mass of a substance. Now let's start with Avogadro's constant. We all know that the value of Avogadro's constant is 6.02 times 10 raised to the power 23. So it all depends on the question given, or it all depends on the values given in the question. If the value requires a Avogadro's constant, like in the question we're going to have number of particles. To find the number of mole, we have to have the number of particles and the number of particles of the substance which we are looking for in mole, and the number of Avogadro's constant. So for example, we're using this formula if such a question is asked to find the number of mole of a substance using Avogadro's constant. So we're having something like this: mole is equal to number of particles over Avogadro's constant, or you say number of particles over 6.02 times 10 raised to the power 3. This is a simple formula of finding the number of moles using Avogadro's constant. Don't forget, in the question you must be given the number of particles, and the number of particles could either be number of atoms, number of molecules, or number of ions. Now, the number of particles could either be one of the three. It is a number of atoms, number of molecules, or number of ions. And why is it like that? If the question is dealing with just a single element, that's a number of atoms. And if the question is involving group of elements, that is a compound, that's when we have a molecule, because compound exists as molecule while a single element exists as an atom. And if the question is dealing with either a single element or a group of elements possessing a charge, a single element or a group of elements possessing a charge, we are going to be having number of ions. So for example, atom sodium is an atom, and molecule, that's sodium chloride, and the number of ions, it is something like this: sodium ion, or we have something like sodium chloride ion, something like that. So when we have something like possessing either positive or negative charge, we are going to consider the we are going to consider it to be ion. So we're going to be using number of ion instead of number of atoms or molecules. So in this case, let's come back to the formula again. If the question is involving atom, we replace this number of particles with number of atoms. If the question is involving molecules, that is group of elements combined together, we are going to be replacing this number of particles by molecules. And if it is involving ions possessing charge, that is anything possessing charge, it could be other element, it could be compound possessing a charge. So we are going to replace the number of particles with ions. These are the three main particles. We have atom, molecules, and ion. The second way of finding the number of moles is using the molar volume of gas at STP. In this case, to use this, you must the question or the substance involved in the question must be in gaseous form, must be in gaseous state. So to find out the number of mole of a substance using this, you have to use this formula: mole is equals to volume of gas involved over what? Over molar volume at STP, over molar volume at STP. So we can also write it like this: volume of gas involved over 22.4 dm cube. Volume of gas over 22.4 dm cube. Another important thing to note here is that the volume of gas here must also exist as dm cube, not centimeter cube. Please note that in this case to dm cube, not centimeter cube. So since we are having the molar volume existing as dm cube, the volume of the gas must also be in dm cube. So that, and if you are given the volume of the gas, if it is given in centimeter cube, you can easily convert it from centimeter cube to dm cube. And how? Just divide by 1,000. For example, if you are having 5,000 centimeter cube, you can easily convert centimeter cube to dm cube by dividing by 1,000. It's going to be 5,000 over 1,000. So this is going to give us 5 dm cube. So to get the number of mole of a substance using the molar volume of gas at STP, like in the question we have to, like, they must give us the value of the volume of the gas, and then we must, before we move on with our calculation, we must ensure that the volume is in dm cube, and then the substance is involved is existing in its gaseous form, not solid or liquid. The substance involved must be in gaseous form. While the third way of finding the number of mole of a substance is using the mass and the molar mass of the substance. Here, this is a simple formula. Mole is equal to mass over molar mass. Mass over molar mass. The unit of the mass here is in gram, while the unit of the molar mass here is gram per mole. Gram per mole. So these are the simple ways of finding the number of mole of a substance when asked in questions. So just look at the values. If the values involve the values given in the question involve the Avogadro's constant and the number of particles, that is either number of atoms, molecules, or ion, we use this method. If the question involves molar volume of gas at STP, which is 22.4 dm cube, we use this method, and we make sure the volume of the gas is also existing in dm cube. And before we can use this method, please note, we must ensure that the volume of the substance is existing in its gaseous form, and in this case, mass and molar mass of a substance. With this, once we're given the mass and the molar mass, we can find the number of moles. Another thing I want you to take note is that in some question they won't give you the value of the Avogadro's constant, because they expect you, what they expect is that they expect you already know about the Avogadro's constant. So they may give you the number of particles of any of these, could be atom, molecules, or ion. It depends on the kind of substance involved. So when they give you something like this, the next thing is to look at it. Since they gave you something like that and they asked to find the number of mole, the next thing is just to find the Avogadro's constant. So you have to know this, because not all the time they present it or add it to question. The same thing applicable to the molar volume of gas at STP, which is 22.4 dm cube, is something you have to know by heart or offhand in case they give a question on it. Because sometimes they will give you just the volume of the gas involved and they ask to find the mole. Just the volume of the gas, that's the only single value they may give sometimes. So when you're asked to find the volume of the gas, so just think of the mole of the gas, just think of the molar volume at STP, then use this formula, you're going to get the mole. And the last one, you'll be given the mass and the molar mass. Sometimes you have to ask for the mole, you have to find the value of the molar mass when the substance involved is a compound, is not an atom. So you have to find the molar mass yourself by addition of the relative atomic mass of each atom present in the compound. You get the value. So please subscribe, like, share, and comment on this video. Thanks for watching. Thank you, and then God bless you.